Hey geometry students, what's up? Alright, section 3.4 is going on right now. We are going to try in this section to find the slopes of lines and use the slopes of lines. You've got two goals. You can see the first one on your screen right now. One of those goals is that you will find the slope of a line from a graph or with a formula. Alright, something you've done in Algebra 1 before, and it's going to become very important to you in geometry as well. Finding the slope of a line from a graph or with a formula. And then the second goal, both of which we're going to address in this video, you're going to learn to use slopes in order to determine whether two lines are parallel, perpendicular, or neither. Alright, very simple goals. Let's go for it now. I want to start off with just how you find the slope of a line. And I've got a couple of lines in a picture right here, line L1 and L2, and we're going to talk about a couple different ways that you can find the slope of a line. Alright, now one of those ways is if you know the simple relationship for what slope is. Slope is just a ratio, and it's a ratio between two specific quantities. The slope of a line is the ratio between the rise and run between 2 points on the graph of a line. Alright, the ratio between the rise and run for 2 points on a line. Now that's easily done if you're given the graph of the line. It's easily found simply by counting the rise and run between 2 points. For instance, look at line L1. I've given you the coordinates of 2 points, or at least shown you 2 points that are on that line. And in order to find the slope of that line, what we can do is just simply count the rise, which in this case goes down, and the run between those 2 points, which I'll draw on the graph, the rise and the run. So the rise, we would be going down, that's 4 units, and we would be going to the right, 1, 2, 3, 4, 5, 6, 7, 8 units, right? So for line L1, whose slope I will refer to as the first slope, the rise was -4, because when it went down, that's why the rise was negative. And we went to the right 8, so that means the run is +8, which is equal to -1/2. Okay? And we could do the same thing with the other line, L2. The rise from the first point to the second point that you see on that line, you go up 2, and then you go over 6. So, the second slope, we went up 2, so that was a positive rise. We went right 6, that was a positive run. And that simplifies to 1/3. Always simplify your slopes. Okay, that's one way of finding the slope of a line. And of course you know another, which I'll show you how that works with these lines as well. You know how to use a formula called the slope formula. And truly all that formula does that I'm writing is it finds the rise and run between 2 points if you're given the coordinates of those 2 points. But you know the formula is y2 minus y1 over x2 minus x1. Now let's use that to calculate the slope for line 1. First we need to know the coordinates of those 2 points that we're trying to find the slope between. So I'm going to write those on the graph. Alright, and simply we pick one of these points to have our x1 and y1 coordinates. I normally go from left to right, so I'll choose this point as the x1 comma y1. And this point is the x2 comma y2, and we'll simply plug their values into the formula. So that would tell us that the slope would be 2 minus 6 over 4 minus -4. Now 2 minus 6 is -4. Remember that was our rise before we went down 4 units. It's still on the picture over there. And 4 minus -4 is equal to 8. Remember that was our run from here to here. I forgot to actually write the number down there, but that was 8 units. So this formula just told us the rise over the run again, and it still simplified to -1/2 like we had before. Now you can use that formula to verify that the slope of line L2 was 1/3, but it will work. I'll leave that to you if you want to verify. Well, that's how you find slopes. That was goal 1. The second goal, remember, is that we're going to be finding slopes of parallel lines, or rather using slopes to determine if two lines are parallel. Alright, and here's what I would like us to do with this picture that you see. I want us to draw a line through that point A that you see on the screen, which is parallel to the given line, the one that's already there. And in order to do that, we're going to need to know what the relationship between the slopes of parallel lines is. And by now, I think you're pretty familiar with this actually. If two lines are parallel, then their slopes are equal to one another, which I'm going to write this way. If a line 1 is parallel to a line 2, then the slope of line 1 is equal to the slope of line 2. Alright, so back to this problem right here where we're trying to draw the line that's parallel to this line through point A. We can do that if we know the slope of the line that is given to us. And we can just use rise over run or the slope formula to figure that out. I think you can see here that we go up 3 units and right 4 units from this point to this point. So the slope is 3/4. Alright, well I'm just calling this first line, line 1. Alright, its slope is 3/4. Well, all we're going to do then to draw a line that's parallel to it is draw another line that has a slope of 3/4. So from point A, I'm going to go up 3 units. I'm going to go over 4 units. That means one more there. And I'll just draw a line through those 2 points, and it will be parallel to the first line that we drew. Alright, there you go. There's 2 parallel lines. They're parallel because they have the same slope. Well, let's talk about the slopes of perpendicular lines real quick. Alright, you got the same picture that I had a moment ago. This time, instead of drawing a line through A that's parallel to the given line, we're going to draw a line through point A that's perpendicular to the given line. Alright, now we already know the slope of that first line is 3/4. Now we just need to know the relationship between perpendicular lines, the slopes of perpendicular lines. Alright, and I'll write that out this way. Actually, there are 2 things that you can do to describe the slope between perpendicular lines. If 2 lines, L1 and L2, are perpendicular, one relationship that their slopes will have is that they'll be opposite reciprocals, or in other words, the first slope will be -1 divided by the second slope. That means opposite reciprocals. Okay. Or another way of thinking about it, since when you multiply opposite reciprocals you always get -1, is that the slope, the first slope times the second slope, that's a multiplication symbol there in the middle. I'll try to make that more clear. Is equal to -1. Okay, now the opposite reciprocal idea tends to be the easiest to use, but the product being -1 is important to know as well. Well, if the first slope is 3/4, then the opposite reciprocal, or the slope of a line that would be perpendicular to it, would be -4/3. Okay, now those are opposite reciprocals. I also want to show you this. If you multiply those slopes, 3/4 times -4/3 is equal to -12 over 12, which is equal to -1, right? Okay, anyway, so any line that's perpendicular to that given line is going to have a slope of -4/3, meaning your rise has to be -4 or +4, and then your run is going to be the 3 with the opposite sign of that. For me, to fit this on the graph, this is the way I'm going to do it. I'm going to go up 4 and left 3. Okay, up 4 and left 3. And I'm going to make a line through there. Alright, now you can see that the slope of that line was -4/3, right? I didn't go exactly in the order you'd expect to, but you definitely go down 4 and you go right 3, so -4/3. And you can see, more importantly, that when those 2 lines intersect one another, they form a right angle. Right? Okay, you know the relationships that you need to know. Let's go ahead and apply that to a couple problems, and these will be the last problems before the video is done. There's some directions here that I want to read through with you. I know it's a lot. You can pause and copy this down first if you like. What I would like us to be able to do is to determine whether the lines through the given points are parallel, perpendicular, or neither. Now this time I didn't give you the graphs of the lines. So we're going to need to calculate the slopes using the slope formula and then compare the slopes to see which of those three relationships these two lines would have to one another. Alright, take the time and find the slope for line 1 and line 2. I'm going to let you pause the video to do that. Then I'll write the answers myself, of course, and we'll analyze based on that information. Alright, you see the slope for line 1 in progress there, which ends up giving you 5 over negative 3. And I don't like leaving negative signs as a denominator, so we'll make that negative 5/3. Alright, then for line 2, you see the substitutions I made into the slope formula, and you find out that the slope is 3/5. Alright, so those are the slopes of the lines, and are they parallel, perpendicular, or neither? Well, the slopes aren't equal, so they're not parallel. The slopes are, however, opposite reciprocals, right? Negative 5/3 is the opposite reciprocal of 3/5, okay? Or you might even note that this is true. Negative 5/3 times 3/5 is equal to negative 15 over 15, which is negative 1. All right, that's a couple of different ways of explaining that these two lines are perpendicular to one another, and so let me write that. I could have written out the word perpendicular. I chose to write that L1 is perpendicular to L2. Got one more example for you to try. Same concept. Alright, there's two lines. Pause the video, find the slopes, see if you can determine whether these two lines are parallel, perpendicular, or neither using the facts that we've been teaching so far. Do it. Alright, slope 1, 18 minus 6 over 0 minus 3, that's 12 over negative 3, which is equal to negative 4 in simplest terms. And then here's slope 2. Alright, not the easiest of numbers, but not the most difficult of numbers to work with. 7 halves minus negative 1 half is equal to 8 halves, and 8 halves is simply equal to 4. Alright, that's the numerator. Then negative 1 minus negative 2 is the same as negative 1 plus 2, which is 1, and that's equal to positive 4. Now let's compare the slopes. They're not equal to one another because negative 4 is not equal to 4. They're also not opposite reciprocals. Even though this one's negative and that one's positive, 4 is not its own reciprocal like 1 is. Well, since these slopes fit neither qualification, these lines are neither perpendicular nor are they parallel, and so our answer then, of course, is neither. There you go. That's it for section 3.4, finding slopes of lines and using slopes to determine if two lines are parallel, perpendicular, or neither. Thanks for watching. See ya.